the use of a Cox proportional hazards regression model, including terms for pool, center, and treatment. Pooling was performed to account for study centers that recruited fewer than 4 patients. P-values were calculated with the use of the Wald chi-square statistic.
Okay, wait there. How many patients? Fewer than what?
4.
And what do you have to have?
At least 5.
So if you don't, then you have to shift to a non-parametric, and I talked about this in class. If it's too small, and it should be parametric, you may see them apply non-parametrics because it's too
So it's
small.
not like they're using the wrong test on purpose, they just needed to compensate for the fact that they have fewer than 4 patients in some centers. Are we good?
Yeah.
All right.
So then the test is approved.
Yes, in this case. So this is an exception. Anything else in the methods you want to review before we move on to results? We have until 1, it's 12:15. We got to cover the other 2 articles.
I want to quickly review the table.
Okay, so results. Patients. A total of 7,384 patients underwent randomization, and 7,376 patients received at least 1 dose of the study medication. So they received, magic word for? Modified intention to treat. Okay. The baseline characteristics, which is usually in table 1, right? Of the patients, including coexisting conditions, were balanced between the treatment groups. When you guys go to table 1, there are no p-values to let you know that there's no difference between the characteristics, right?
Right.
But it's telling you here that they're balanced. So you can assume that they're all fine and that there's no significant difference between the groups. Yes?
Yes.
Next, let's go to the actual figure 1 flow diagram. Okay, so 7384 underwent randomization. Tiotropium 3711, salmeterol 3673. That's your intention to treat. Yes? And then it says 4 did not receive tiotropium, 4 did not receive salmeterol. Next line, 3707 were included in efficacy and safety analysis. What is that? Modified intention to treat. Why do you know that? Because above it said did not receive. So that means that the 3707 are the ones that did receive. It doesn't blatantly say receive, but based on the line above, you can deduce that that is your modified intention to treat.
Yeah.
Yes?
Yes.
Those numbers there match up with what they're saying in the first line of the results, right? 3707, 3669, we're good. At the end, the 3122 completed the study. 3021 completed the study. What is that? Per protocol. All right. Next in the results, exacerbations. The time to the first exacerbation, the primary endpoint, was increased by 42 days with tiotropium as compared with salmeterol. Does everybody see that? 187 days versus 145 days. Representing the time until at least 25% of the patients had a first exacerbation. This corresponding to a 17% reduction in risk with tiotropium. Then it gives you a hazard ratio. Dr. Garcia, question. It says hazard ratio 0.83. So when it says 0.83, 1 minus that is the 0.17, and that's how you know that it's a 17% reduction. So anytime you have a hazard ratio, whatever that number is, you subtract 1, and that's the percent reduction. Make sense?
Can you say that one more time?
One more time.
How about you draw it?
All right. Here.
Flip your board.
It's 1 minus 0.8.
Lock it, right? Lock it. Okay. Hazard ratio 0.83. Right? In the line it says corresponding to a 17% risk reduction. Right? So 1 minus 0.83, everybody agrees, is 17, right?
Yeah.
Yes? So this times 100 gives you the percent risk reduction. So when you go in all these other articles and they tell you, for example, the hazard ratio is 0.72, that's gonna mean that it is a 28% decrease or whatever you're trying to look at. Make sense?
Yep.
All right.
What if your hazard ratio was 2.13?
There's an association.
There's always an association. You're dealing with ratios. If your hazard
If
ratio
it's
is
over 1, it means an increase of something, right?
Yeah.
So in this case, let's say it's 113% increase. Does that make sense? Dr. Wesley?
well, yeah.
I think it
that's-
makes sense.
mhm. Because think about it. What do we know about? There's 3 ways you can read a ratio.
Less than, equal to, greater than.
What is your hazard ratio? Right at 0.83.
It's less than one.
So what do you know it's doing?
Reducing.
Okay. And what about 2.13? Because of why?
It's greater than one.
We're good? Any questions on this? No? Nothing? Okay, I'm going to the next page. Below figure 1, the paragraph that says tiotropium as compared with salmeterol significantly reduced the risk of moderate exacerbations by 14%. Notice how the hazard ratio is 0.86. Confidence interval, very significant. Severe exacerbations,
Where are you? Where are you?
under figure 1.
Okay.
All right. Severe exacerbations by 28%. Hazard ratio 0.72. Look at that. Yes? It wasn't a coincidence, by the way. So Kaplan-Meier for the time to the first severe exacerbation is shown in figure 2C. So let's go to Kaplan-Meier. Figure 2C. Everybody see it, the last one. So that is what we just read. The severe exacerbations, hazard ratio is 0.72, which means 28% reduction with tiotropium in severe exacerbations compared to salmeterol. We're good?
Yep.
All right. Back to the article. Anything else you want to look at there?
That's an awful heavy sigh.
Speak up now or forever hold your peace.
Did they make power?
Did they mean power? Yeah.
Did they mean
I-
power? Let's talk about power.
I have a question.
Yes, ma'am.
For baseline, when we have to look at the information underneath the table, if they say that they're missing people or anything like that,
Where are you?
table 1, baseline characteristics.
Table 1, okay.
It says
Baseline?
like they missed 15 people.
Right.
Like,
For duration of COPD, right?
yeah.
Data on duration of COPD, we're missing 15 patients in tiotropium and 5 in the salmeterol group.
That's something that like we have to like.
Dr. Garcia, here to chime in?
What is the point of that table?
So there's a difference at baseline.
And what do you know?
No difference.
So you can assume that the 15 people missing and the 5 people missing
It wasn't significant.
to make a difference.
Okay.
Because they said in the article that everything was
So is there truly no difference, or is it reported?
reported. You
That
can't
there's
tell
no
because you don't have the data, you just have to take
Yeah,
your
that's
word for it.
right.
Okay, got it. Okay.
Okay, so the power. Let's go back. Okay, power. We needed 6,800, right? They used what analysis?
Modify.
Modified intention to treat, and that adds up to 7,003 something, right?
Yeah.
7,376. So, did it meet power?
Yeah.
Yes? You can agree that this is more than this, so it did meet power.
Yeah.
Any questions on power in this article?
No.
Anything else you want to look at?
Patients with a low body mass index.
Okay, so, in table 1, the page with table 1, on the right, the paragraph that starts with the effects of tiotropium as compared with salmeterol. Right? If you go down to the next sentence, it says patients with a low BMI or very severe COPD seem to benefit most from tiotropium therapy, figure 3. So go to figure 3. In figure 3, you can see that stage 4 COPD and BMI are the two lines the most to the left of it. Yes, so that's the biggest, what is it? It's the biggest benefit from tiotropium were in these two classes of patients. However, look at the p-values for the interaction. In the case of BMI, the p-value is 0.17.
Non-significant.
It's non-significant, right?
Yep.
We had a question. That 0.17 applies to all the BMIs there? Less than 20, 20 to 25, 25 to 30?
But the individual confidence interval didn't cross 1.
Yeah, but that's if it can, you can.
Usually
That means it's
The
significant.
BMI goes to each level,
Isn't it confidence interval just
right?
constructed
And then the
to
p-value
with this
for the
article?
overall interaction.
P-value.
So that 0.17 goes to all 4 subgroups of the BMI?
Yeah, like the bar, right? Right, your ratio line, I mean your, oh poop, I'm having a
Plot?
brain fart.
The
The size of your interval, right? And where it lies on the line, everyone is individual, right? And then they compare those, right? They do a statistical analysis of those and come up with a p-value, right? Now, in the big picture, what is that about?
The p-value?
BMI?
Not really, but
It's not really significant.
Is that part of your primary?
Nope.
Your secondary?
Not
Not mentioned.
very
No.
significant.
Right? So there may be something mathematical about that, and maybe down the line they want to see if, if you're chubby, you have a harder time with your COPD, which, what do we know about obesity and respiratory issues?
Yeah.
Not good.
Okay? So there is always going to be information that's not relevant.
But they just
Such
put it
as
in.
You gotta
distractions.
figure out what matters and what doesn't matter, right?
This
Because
one,
this would be one of those blinder things, bzzz, right into the chart. What do you need to be looking at?
Big picture?
significant. This one, remember, they're looking at exacerbations in COPD. The biggest benefit, which is statistically significant, and stage 4 COPD. All right, so this one is very important, hence the little stars.
But the p-value is 0.05 though.
Yes, so it's significant in this one.
I have a question.
Yes.
So when we are determining if it's
Is it supposed to be less than?
Wait,
this?
one at a time, one at a time.
Oh,
I cannot take 3 or 4.
What?
First question.
Isn't it supposed to be less than 0.05?
not
Less
less
than
or equal to, I thought it was less than.
What does it tell you?
Less than 0.5, less than 0.05 for it to be significant.
So it's not significant.
No.
It is not significant.
It is not, okay.
just missed it slightly. So my question is, do we determine if it's significant or not based on the p-value or based on the confidence interval?
Based on the p-value.
They should match up. No?
Isn't the p-value for the study itself and the
Yes,
confidence
p-values for the
interval
study, the confidence interval is for the population.
of interest, if you can extract.
Yeah, that is true, but in this table, I mean, it's clear that because it doesn't cross the zero line, it's significant. But to confirm it, do we find it out from the p-value or from the confidence interval? I always do the confidence interval, but I just want to double check.
Yeah, I'm so best.
Any
Garcia.
insight as to this?
What does the p-value represent?
Statistical.
Each line or each characteristic as a group?
As a group,
So can you apply the p-value to each individual line?
no.
No. So if you think that the p-value is significant, then within those things, you have to see what is,
Confidence.
right?
What is what?
Confidence.
In the confidence interval,
If there's
which one
in
is,
there,
right?
then it would be non-significant. That's what you're saying?
Yeah.
So the confidence interval here is 0.5 to 0.81 for the stage 4.
What did they tell you in your manuscript as significance?
Patients with low BMI or very severe COPD seemed to benefit most from tiotropium therapy.
Is seemed to benefit most
That is bias.
statistically and clinically significant?
No.
So is your p less than 0.05?
No.
So
none of
wouldn't that
these-
make sense why they're saying it that way?
So it's trending or seeming that way, but it's not exactly that way based on statistics. Yes, can we all agree with that?
No,
Dr. Garcia seems to agree with it.
there's not at all, right? It's trending.
Yes? So at best, seem equals trend, but no significance. Neither statistically nor clinically, right? Just a trend. Yes? Does that make sense?
Yeah.
All right. Is there anything else here you want to see before we
Yeah,
move
the
on?
one, and the one is in the confidence interval.
What are you?
It says there is a one there.
But, yeah.
Okay. The one, what about it?
I forgot
Right,
what she
I
said
know,
about
I
it.
But, it doesn't
But
really.
What is
is
your
it, there's a
question?
one or there's a zero here?
Okay, so, quick recap.
And if it's a one,
There's
it's
two
positive.
types of graphs. There's 0, there's 1. 0, you have a risk reduction of some sort. It is either absolute or relative to get 0. In order for you to have 0, you need to see where am I going from to see what I'm reducing. That means you need some sort of baseline. You started here, you reduced 20%, makes sense. Yes? No? Maybe? Perhaps? We'll assume that that makes sense. 1 is either odds ratio, risk ratio, hazard ratio. What do they all have in common? These ratios, right? That means you have a 1 here. 1, if it's less than 1, you have a reduction of some sort. If it's greater than 1, you have an increase of some sort.
And if it's equal to 1,
No change,
Yeah.
right? Okay, so relative risk, group A versus group B, right? Let's say group A is twice as likely as group B to get COPD. That's relative risk. I'm comparing me, group A, to you, group B. All right? The example she gave us in class, N equals 100. You have treatment, you have control, right? 50 people in the treatment get it. So if you have 100 and 50 got it, how many did not get it? 50. All right. 50 got it, 50 didn't get it. In the control, 25 people got it,
75.
75 did not get it. What is 50 over 50? 1. What is this? 1/3. 1 to 1/3 equals 3 to 1, right? Odds ratio 3 to 1. Relative risk ratio 2 to 1. You see how using the exact same numbers, I can make it seem much better here than it is here, using odds versus relative risk. Yes? So, authors, such as in the smoking trial, will try to use odds ratio to make varenicline seem much better than what it is. If you're trying to reduce a risk of some sort or something bad, you're going to use relative risk to say, oh, it's only this much, as
Yeah.
opposed to
It's more.
overestimating it with odds. That's how you use these things to benefit you.
Manipulate.
She is cheering over there,
Wait,
doing a
can
dance.
Can you say that again?
Okay, what do you want me to repeat?
About.
Odds ratio always overestimates the treatment effect. Always. It will seem much better than what it is, or it will seem much worse than what it is. Does that make sense?
Yeah.
So, if you're an author, you're trying to get your drug approved or whatever, I'm going to use my odds ratio for benefit, right? Such as varenicline. It's much better. Odds ratio. If I'm trying to like prevent something or a side effect, I don't really like that side effect of my drug, I'm just going to say relative risk. It's, let's say my relative risk is, like 30%, right? But my odds ratio will be more than that. So I'm going to use just 30% as my side effect. Does that make sense? I'm trying to use a less number to benefit me.
Yeah.
That's how you use relative risk and odds ratio. So that's where you get the 1, and you get all the little things like this. And then the 0 is a risk reduction of some sort. Baseline, you went down a certain amount, either absolute or relative, but it's always a risk reduction, the 0.
So in the Vericlinic trial, the Changes trial, they reported an odds ratio because it looked better because it had a positive protective effect.
Yes.
It is manipulated.
Okay.
Made it look better.
Yes, correct. Any other questions on this one? Before we move on. We're good on this one.
Yeah.
Let's move on to otitis media.
Right, they only want one division, that's what could be the problem.
I'm gonna grab some.
Should we stop and then record for the next one?